Okay, Professor Jim Schultz here for my Finance 680, Finance 311. Any random YouTube viewers that might be interested in learning about some bond math, I wanted to go ahead and put this video together like I said I would, kind of showing you guys how you would solve a bond valuation problem using the formulas as opposed to using strictly the calculator, which is pretty much what we do in my classes given the introductory nature of the material in my classes. And so let's go ahead and I've actually got two examples planned for you guys. So let's go ahead and kind of go through how this math falls together. So let's say you have a 4-year bond that pays a 5% annual coupon. The yield to maturity is 8%. What is the current price of the bond? Alright, so here's what the timeline would look like, which is pretty standard, pretty basic. Alright, here's one way that you could solve for the present value of the bond, because remember, when you're looking for the price, you're solving for the present value. You could simply break out each cash flow, treat it as a future value, and then use the basic time value of money formula, which is obviously present value is equal to future value divided by 1 plus I raised to the n. So you essentially just see that formula repeated 4 times that represent each of the future cash flows. Add up all your numbers and you get $900.64. If you actually went through the calculator keys, present value, future value, I, payment, and N, you would see that you also get $900.64. So this is one way that you could solve this problem. But if we scroll down, there's actually another way that you could solve this problem. Okay, so you could take the same timeline and you could apply the annuity formula to the coupon payments. Because if you look back at the timeline, let's scroll back up. Look at the timeline. This $50 coupon payment is an annuity, and there is a specific formula to handle annuities in finance. We don't cover it in my class simply because my class is intro in nature, and I feel like having a firm understanding on something like this is beyond the scope of an intro class, and so that's why I kind of leave that on the shelf and we cover other things instead. But this is the present value of an annuity. This right here. This is the present value of an annuity formula. Alright, you can see that thing's it's a little bit involved. Until you use it a few times, it becomes a little tricky in terms of how to apply it. It's basically the cash flow, or whatever the annuity itself is, times, and then in brackets, this term right here, which is 1 minus the expression 1 plus I, that's what's in the parentheses here, raised to the exponent of minus n, so the opposite of n, divided by I. So when we put in the actual numbers here, you've got the cash flow of $50 times 1 minus 1 plus I, where of course I is your YTM, which it was up here too. I don't think I mentioned that explicitly, but just for completeness, your I, of course, in a bond problem is your YTM. So you've got 1 minus 1.08 raised to the negative 4, because we have 4 periods, so obviously our n is going to be 4, divided by 0.08. So you get $165 and almost 61 cents. That represents the present value of this coupon annuity, basically. So those 4 $50 coupons that you're receiving over time, if you had to put a value on those coupons today, it would be $165 and almost 61 cents. So then you take that, and then you also have to handle the $1,000 par payment you're getting back at the end of the bond's life, which you can simply use the basic time value of money formula to handle that guy, because it's just a one-time payment. It is a lump sum. So you have your future value divided by 1 plus I raised to the n. So you have 1,000 divided by 1.08 raised to the 4th power. You get 735.030. So then you simply sum those two numbers together. You sum your two present values, and not surprisingly, you get $900.64. So that is those are two different ways to solve a bond problem using strictly formulas, not using the calculator and its time value of money applications. Here's a second example, though, that we'll move through a little bit more quickly simply because we kind of now have the hang of it. But I wanted to show you how a semi-annual coupon would differ from an annual coupon, since most of the bond problems you do are on a semi-annual basis. So let's say you have a 3-year bond paying a 4% semi-annual coupon. So obviously that's going to be $40 every year or $20 every 6 months. The yield to maturity is 3%. What is the price? Okay, So here's the timeline: 20 every 6 months, and then 1,000 at the end. This time what I did is I went straight to the present value of an annuity formula. That's what you see right here. You see the same formula that we used up here, right here. Now it's just applied again for a different problem with different numbers. And then I went ahead and added on, this is the present value of the lump sum at the end. So rather than do it in two distinct steps, I went ahead and just put them into the same step. And so this guy right here is going to be applied the exact same way. The only thing I wanted to mention about this is, since your coupons are paid semi-annually, your I and your N have to be input semi-annually. Otherwise, you're not treating the problem the way it should be treated. And so if you have 3% yield to maturity every year, that's going to be 1.5% every 6 months. So you have 1 plus I is 1.015. And then your N here has to be 6. Even though it's 3 years, it is 6 semi-annual periods. This is, again, another instance where the timeline becomes very useful for you. And so you apply the present value of an annuity formula the exact same way. You have 1 minus 1 plus I raised to the negative N divided by 0.015, which is your I again. And then you simply discount the final payment, the par payment, again, using the standard time value money formula. And then you add up those two present values and you get a price of $1,028.48. And you can always check these with your calculator too, doing them the way that we're more comfortable doing them, just to see if you get the same answer, so that you know that you're doing the math correctly. So I hope this was useful for you guys that will be going on in finance, going into 312, going into 681. I know you'll be doing things like this on a more regular basis, so hopefully you can kind of use this as a foundation and a jumping off point. And so this is how you do bond math.